So the question for this example is this simple. Okay, we have a limestone, and this is the composition of the limestone. We have, in a limestone you will have calcium carbonate, magnesium carbonate, and some inert, and the composition is given as 92.89 for calcium carbonate, 5.41 for magnesium carbonate, and 1.70 for inert. And all these things is in the weight balance. Okay, so the process here, the reaction is that by heating the limestone, you recover oxides known as lime. So this is the question. So the reaction that is happening is that your limestone, which has this composition, all these things, if you add this thing, you will get a limestone. You heat it up and you'll get oxides known as lime. So basically what is happening is that, let's say you have limestone, you put in a heat. Okay, so you have heat here and you'll get lime. So this is the reaction that is happening. But in the limestone you have calcium carbonate, magnesium carbonate, and inert, and in the lime also you will have calcium oxide, magnesium oxide, and inert, and other gases. So the question is asking us how much pound of calcium oxide can be made from 1 ton of limestone, how much pound of CO2 can be recovered per pound of limestone, and how many pounds of limestone are needed to make 1 ton of lime. Okay, so in the notes which I have given to you, I think last week, the example is already solved, but today I would like to solve the example together with you with some differences with the way the example was solved in the notes. Okay, so first of all, in any our material balance problem, we should have to choose our basis. Okay, so in the notes, the question was solved by using the basis of 100 pound of limestone. Now again, since if you read the question, there was no basis given to you, so if there were no any basis given to you, you can choose your own basis. Now in this question, since I know that my question is asking me how many pounds of calcium oxide can be made from 1 ton of limestone, so I want to choose my basis to be 1 ton of limestone. So now here we'll see whether you can get the same answer or not if we choose a different basis. So let's say I choose my basis here to be 1 ton. So 1 ton here is also equal to 2000 pound of limestone. So this is my basis. The second thing is that I would like to draw a flow chart and label it. So let's say since this is a heating process, so you can say that the type of reactor is a furnace. Okay, this is a type of reactor. So coming into the reactor is your feed of limestone. So F1, and we know that it is 2000 pound. And then it has a composition of magnesium carbonate, calcium carbonate, and also inert. Okay, and the composition is 92%, 92.8. So I just put it into a fraction, so it becomes 0.9289, 5.41%, so 0.0541, and 1.7%, so it becomes 0.0170. So if you add this, you'll get a fraction of 1. And then we know that our product, so all these things is our limestone, right? And then we are getting our lime, which the composition of lime will be calcium oxide, magnesium oxide, and the inert. So this is your lime composition. Okay, so since this is a chemical reaction, so what we need to do here we have to write the chemical reaction on what is happening from limestone to become lime. So first of all, we look at calcium carbonate. So calcium carbonate, you subject it to heat, you'll get calcium oxide plus CO2 gas. And then you have your magnesium carbonate, plus in heat as well, you'll get magnesium oxide plus CO2. So now if you see here, the label flowchart, we only have limestone, and we get lime. But here, if you look at the reaction, so we also have additional product, which is our carbon dioxide. So I have to put another product stream coming out from the furnace, and this is going to be my CO2. So I can write here, this one is my product stream 1, this one is my product stream 2. Now this is a completely labeled flowchart. So now when we look at our equation, we have to make sure that when we are dealing with chemical reaction, we have to make sure that our equation is balanced. So we have to make sure that everything here, whatever we have on the left hand side is equal to whatever we have on the right hand side. So if I were to say here, I have one calcium over on the left hand side, and I have one on the right hand side, one C here and one C here, 3 oxygen, and I have 1 plus 2, so I have 3 oxygen. So this equation is already balanced. So we do the same thing for magnesium carbonate equation. Magnesium carbonate 1, magnesium is 1, carbon is 1, carbon is 1, oxygen is 3, oxygen is 1 plus 2 plus 1 is 3, so this equation is also balanced. So now we know that this equation is balanced. We can start to solve for our problem. So for question A, the question is asking us how much calcium carbonate is formed per 1 ton of limestone. So again, since this is our chemical reaction, we have to change everything from mass composition to mole composition. So first of all, we have to change the mass of calcium carbonate into mole of calcium carbonate. So we want to find mole of calcium carbonate. So it is equal to, we know that our composition of calcium carbonate is 0.9289, right? And our total feed is 2000 per pound. And then we know that molecular weight. So we need to know the molecular weight for calcium carbonate. So molecular weight for calcium carbonate is 100.1 pound per pound mole. Now here, if you see here, I'm using the unit pound per pound mole, because I know that all my calculation is going to be in pound. So I'm not using the unit of gram per gram mole. So I know that this is my molecular weight. So 101 pound per pound mole. So I will get the mole of calcium carbonate that is going into the furnace is equal to 18.559 pound mole. Okay, so I know this is my mole going in. Now, but I want to find the mass of calcium carbonate. So if we go back to our equation here, we see that the stoichiometric ratio between calcium carbonate and calcium oxide is 1. So in order for me to find the mole of calcium oxide, I know that the ratio is that 1 pound mole of calcium oxide over 1 pound mole of calcium carbonate. This is my stoichiometric ratio. And I already know I have 18.559 pound mole of calcium carbonate. So I can write here 18.559 pound mole of calcium carbonate. So if I do unit cancellation, I can cancel out this unit, I can cancel out this unit. So I know that I can get the amount of mole that I can produce is equal to 18.559 pound mole. Okay, so by saying here, right, so the same thing we can do here. If I say that 1 mole of calcium carbonate will produce 1 mole of calcium oxide. So if I have 18.55 mole of calcium carbonate, I will produce 18.559 pound mole of calcium oxide. So it's basically we are using, so this is how we represent what we are saying just now. So this is we are using the stoichiometric ratio. Now that I have known the mole of calcium carbonate, so I can find the mass of calcium carbonate, mass of calcium oxide. So in order for me to find the mass of calcium oxide, again I have to know the molecular weight of calcium oxide, 56.08, and the unit is still pound per pound mole. So now that I know the molecular weight, I can find the mass of calcium oxide. So this is going to be 18.559 pound mole, and then I times with 56.08 pound per pound mole. Cancel out this unit, I'll get a value of 1041 pound of calcium oxide. So this is for my example A. Now if you compare this answer to the answer in the notes that I given you, you can see that we'll get the same answer even though we are using a different basis. Now for B. Question B is asking us to find mass of CO2 per mass of limestone. Okay, so if you look at our equation just now, we can say that 1 mole of calcium carbonate will produce 1 mole of CO2. So I can say here that mole of CO2 is equal to same as now was 18.559 pound mole, right? But I also know that CO2 was also produced for the magnesium carbonate reaction. So now I have to find how much CO2 were produced for the magnesium carbonate reaction. So in order for me to do that, I have to find first the mole of magnesium carbonate. So mole of magnesium carbonate is equal to, so we know that our composition for magnesium carbonate in our limestone was 0.0541, and you times with 2000 pound, and then you divide with our molecular weight. So the molecular weight of magnesium carbonate is equal to 84.32 pound per pound mole. So I can write here it's 84.32 pound per pound mole. So again, unit cancellation, and we can get the mole of magnesium carbonate in our system is equal to 1.2283 pound mole. So using the same relationship here and using our stoichiometric coefficient and stoichiometric ratio, I can say that 1 mole of magnesium carbonate will produce 1 mole of CO2. So I can say that mole of CO2 is equal to 1.283 pound mole. And then to find the total mole of CO2 is that this mole of 18.559 plus 1.283 283. So I'll get my total CO2 is equal to 19.842. So 19.842 pound mole. Okay, but then the question is asking me to calculate the mass of CO2 per mass of lime. So again, I have to find the mass of CO2. Mass of CO2 is equal to, I know the mole, 19.842 pound mole, and I have to know the molecular weight of CO2. So molecular weight of CO2 is equal to 44 pound per pound mole. So I can write here is 44 pound per pound mole. Cancel out the unit, and then you'll get the value of 873.1 pound. Okay, so the question is asking us the ratio of CO2 over limestone. It's going to be equal to 873.1 divided with 2000. So you get a value of 0.437. So this is the answer for B. Okay, now for C. C is asking us to find how much limestone is needed to produce 1 ton of lime. So if you were to just draw back our flow chart just now, so this is we have here coming in is 2000, and then we have our CO2 just now was 873.1, and then the rest is going to be lime, right? So this is our P1. So from here we can say that we know our P1 is equal to 2000 minus 873.1, which is going to be equal to 1126.9. Okay, so we know that our P1 is equal to 1126.9. The question is asking us how much amount of limestone is needed to produce 1 ton. So here we want to know that if let's say we want to produce lime is equal to 2000 pounds, how much of limestone is needed? So we know that if we have 2000 pounds of limestone, we can only get 1126.9 lime. So if we do a ratio, we can say that in order for us to get 2000 ton, 1 ton or 2000 pound of lime, say that the amount of limestone needed, mass of limestone, in order for us to get 1 ton of lime is equal to 2000 times 2000 over 1126.9. So we can get here the value of 3,549.3. So this is the final answer for C. Meaning that in order for us to get our P here, P equal to 2000 pound, we need our limestone value. Instead of this value, we need to have 3,500 and around 50 pound. So that is this answer for C.